हेलो एवरीवन, वेलकम यू ऑल टू एआई की पाठशाला। एआई की पाठशाला आपकी अपनी पाठशाला है एंड whatever session I am conducting, it's absolutely free of cost. And those of you who want to join my live session, they can go to the description section of the video and join my Telegram group from the link attached there, because I send the joining link in the Telegram group only. So by joining the Telegram group, you can have an access to my all the free live sessions that I am doing. I conduct live session at 9:15 p.m. IST these days, so you can avail the benefit. And on the special request of Mr. Varun Soni, who is a student of NSIQ student, I am taking this session for NumPy, and I think there will be almost 4, maybe more than 4. We can see how the session goes. Session on the NumPy, and that's all. Let me share you my screen. So what I will do first, I will create one GitHub repository for the today's session, and then I will clone that repository in my VS Code, and thereafter we will start coding. And what I request everyone, because I want all these sessions and want everyone not to sit idle and just watch the session. You need to keep typing along with me. You need to keep coding along with me. And if you face any difficulties, and if you are not getting any output, or if you are not able to do something, you can ask me the question. You can interrupt, because the audio channel and video channel is open, so you can interrupt in between and you can ask question. You can even share your screen if you want, and let me see why you are not getting an output and what are the things that you are doing wrong. So in this way, I want to make this session very interactive one, so that whatever you do inside the session, it will be completely hands-on, so that after the session ends, you don't have to do much for your revision. So that's all. So let me first share you my screen. Let's share the screen. Now, first thing that I'm going to do, this is a standard thing that we often do. Let me open you the GitHub. So this is a GitHub. After opening the GitHub, you have to come here in this new, and you have to create one repository. So I'm creating this repository by the name numpy underscore 01. This is the name of my repository, numpy underscore 01. And I am keeping this repository as public. Thereafter, if you want, you can add a readme file. Thereafter, I am adding this gitignore file. Inside this gitignore file, I am adding Python, and I am choosing one license. Let's choose MIT license and create a repository. Is my screen visible to you guys? Please confirm me, either in audio or in chat. And is my voice, audio, is everything clear to you? Kindly confirm me. Kindly confirm me. Fine. So can you guys please confirm me? Is my audio okay? Fine, not an issue. Rakesh Anna? Yes, sir. Okay, fine. Great. So see, I'm copying the URL from here. For copying the URL, you have to click on this green thing, code, and here, just below this HTTPS, you have to click here. If you just click here, it will show you copied. So what I have made one GitHub repository, and I'm cloning this repository in my local system or in my VS Code. So let's open the VS Code. Let's open VS Code. So let me open the VS Code. Fine. So there is an option to clone repository. So I am clicking on it here. Thereafter, just paste this URL, and you have to choose the first option, clone from URL. When I will do that, it will ask me to select a repository destination. So I'm selecting a repository destination. So let's see, let me select the repository destination, and I'm choosing a destination here. Fine. After that, it will start cloning. Then it is asking me, would you like to open the clone repository? Yes, I want. So let me open it. Thereafter, I have to click on yes, I trust the authors. Fine. In this way, my repository is cloned. So whatever I have written there, it's been cloned here. Now, let me do now what I need to do. So okay, let me do one thing. Let me check it because sometimes it happens. So let me share you my screen first. Let's say advanced, then portion of the screen. Share. Fine. Now, fine. So you have to, I'm clicking on here on this new file, and I'm making one file here. So just let's make one file here, and I'm giving the name of this file basic underscore numpy underscore 1. This is the dot ipynb, because this is a ipynb file. So that's why I've given the name dot ipynb file. It's detecting the kernel, select kernel, then Python environment, and I'm choosing this 3.11.3 environment. So it's done. My file has been created now. So now let's try to understand what is this numpy. So I suppose I will write here only. This was really good. So see, numpy is one of the most important packages in Python. I have already covered what is packages, what is libraries, what is modules in the basic Python, and those of you who don't have the understanding, I will attach the link of that video. You can refer to that videos. So the today's agenda is my NumPy. NumPy is one of the most important packages in Python for numerical and scientific calculations. And NumPy is extensively used in data science, machine learning, and AI. NumPy is used not only in these fields, it is used in a lot of scientific areas. That is not only confined to the computer science, but it is also used in physics. It is used in quantum computing. It is used in statistical computing. It is used in signal processing. It is used in image processing, graphs and network, even in astronomy, and even in cognitive psychology. So it has got a very wide range of application areas. Nearly every scientist working in Python draws on the power of NumPy. NumPy brings the computational power of languages like C and Fortran to Python. So basically how NumPy is built? It is built in the language C and Fortran, which is much easier to learn and use. With this simplicity, a solution in NumPy is often very clear and elegant. It is one of the most powerful numerical processing libraries in whole of Python. So now let's see what this all thing that I have told you. This is just a brief introduction of NumPy. Now, NumPy, first thing is we can write NumPy as NumPy arrays. one most important thing that I wanted to tell you is that since we are learning Python, so there is not a concept, there is no concept of array in Python. There is no concept of array in Python. In Python, the concept of array doesn't exist in core Python. When I am talking about Python, I mean core Python. So in Python, instead of this array, there is a concept of list, which we have already discussed. So instead of this array, we use, but in other, if you will talk about the other programming languages, like let's say C++ or Java and other, there the concept of array remains. But in core Python, concept of array is not there. Instead of this array, we use list. But NumPy is one library of Python. NumPy is one library of Python where the concept of array exists. Concept of array doesn't exist in core Python, but it exists in NumPy, which is a library of Python. So here the whole NumPy is basically this concept of array is central to the whole NumPy thing. We will see this with the help of code just in some time. So this is a high level, few things that you need to understand. This is a high level, L-E-V-E-L level, number objects, in what it means, number objects, integer, and floating point. So what are the main advantages of using the NumPy? First thing is that it provides extensions for multi-dimensional arrays. Multi-dimensional arrays. Second thing, I am saving these, whatever I am writing, it's already saving. I will upload this in the GitHub. So even if you are not able to write, it's fine. Second thing is that it is very efficient. Efficiency wise, it is super duper efficient. That's why NumPy is, because of the efficiency, we will see how this is much more efficient. And it is designed specifically for scientific computation. Designed specifically for scientific computation. Scientific computations. Computing or computation. So these are some of the major benefits of using the array. Now, one question arises in most of the people's, what is the difference between this Python list versus NumPy? What is the difference between Python list and this NumPy? So, okay. See, this NumPy gives us an enormous range of efficient ways for creating arrays, for creating arrays, for creating arrays, and manipulating numerical data inside them, and manipulating manipulating numerical data inside it. So this is the most important thing of NumPy. It is used for creating the arrays, and manipulating numerical data inside it. While Python list contain different data types within a single list, Python list, we have already discussed the Python list. Let's say this is a Python list, and it contains different data types within a single list. We have already discussed inside a Python list, we can have the same data type or with a range of or different data types. All of the elements in a NumPy array should be homogeneous. Here in Python list, it is not necessary to be homogeneous, not homogeneous. We can have different types of data, but inside this NumPy, all the elements should be homogeneous. Fine. One important point that I would like to tell you, that the mathematical operation that we perform in our Python list is extremely inefficient or not very much efficient. But the same operation that we perform inside our NumPy is very much efficient. We will see this also with the help of code, how this is much more efficient as compared to the Python list, how NumPy is much more efficient than our Python list. Fine. So this is all about, we will keep on understanding the theory, but let me switch to the coding part. So all of you should open your Jupyter notebook, and before starting, let me tell you something more. Okay, let me tell you something more first before starting. See, first thing is called one-dimensional array. 1D array. 1D array. It is called one-dimensional array. So it can be represented in this way. This is a representation. So we can write something inside it. Let's write 1, 2, 3. This is called one-dimensional array. And the one-dimensional array is also known as vector, or you can say array. Either you can call vector or you can call it an array. Now, thereafter comes the 2D array, two-dimensional array. 2D array, which we can write in this way. Let's say this is a two-dimensional array. Let's write 1, 2, 3, 4, 5, 6. This two-dimensional array is also called matrix. Two-dimensional array is called matrix. Fine. After that comes the 3D array, 3-dimensional array. So 3D array is something like, let me draw like this. 3D array is something like this. Let's like, it's something like a cube. Can you see this? This is like a cuboid, and there is a small, it is made up of this small cuboids inside it. This is sum of these small cuboids. This 3D array is also called tensor. T-N-S-O-R. And the array that is above 2D is, we can simply call these arrays which is above, whose dimension is above 2D, we can call it ND array. ND array. Who is Alex? Are you Varun? You are Alex? Varun, are you Alex?
No, sir.
Okay. So Varun has gone.
Oh, no, sir. Sorry. By mistake. Yes, sir. Alex is me only.
Alex is?
Sir, Varun. Sir, I am only Alex.
Okay.
Sir, I switched to my computer. That's why I forgot.
Okay. So I thought why Varun has the how, because see. So if
No, sir.
fine. Not an issue. Okay, great. So let me. So this, pardon me for my handwriting because I am very new to writing on this board. So I am still learning. So see, so this 1D array, whatever dimension which is above 2D, that is even 3D dimension or above 3D dimensions, we used to call it ND array. An ND array or dimensional of array which is above 2D is called tensor. We will understand this, we will use this tensor, even matrix, vector, tensor, all these things we are going to use very extensively inside our inside the AI, or in machine learning, in deep learning, in lot many places we are going to use these concepts, the concept of tensor. Even the TensorFlow, there is one library called TensorFlow. This is a library of deep learning. So when we will learn the deep learning, this library will come into picture. So it is made up of the tensors. TensorFlow is basically made up of tensors. So this is just a basic introduction of what is 1D array, what is 2D array, what is 3D array, how this looks. Just, and visually you can only visualize this 3D array. 3D array is just like, let's say, cuboid. So you can visually understand only the till 3D array. After 3D array, it's impossible to visualize by the present sense perception. We are not able to visualize anything above 3D array. But mathematically, it is possible to solve the questions. So what actually we do, whatever concept that applies in 3D array mathematically, whatever mathematics is applicable in 3D array, we extend that mathematics to the ND array. So everything that is true in 3D array, we assume that that should be true in n-dimensional array also. This is how the logic and mathematics works in n-dimensional space or n-dimensional array. So this was just a brief introduction. Now let's move to the coding part and see, with the help of this coding, we will going to understand and keep on understanding these things. So first, first thing that you should need to do is that first you have to need to install the NumPy inside your system. To use the NumPy, you have to install the NumPy. So how you will install the NumPy? You have to write pip, pip, since you guys are using Jupyter notebook, so you need to write pip install install, and then you have to write numpy, py, pip install numpy. And if you simply run this code, pip install numpy, let's see what happens. It's telling me requirement already satisfied. That means it is already installed in my system. Fine. And it is also giving me this message to update, run this. So let me copy this. So you guys, since you guys are using it, maybe using it for the first time, so it must not be installed in your system. So you have, if you will do, you will get another, you will not get this message requirement already satisfied. It will first keep on installing. After that it will get installed. Then this message, if you run it second time, then you will get this message requirement already satisfied. Now it is asking me to update pip. So for this, to update, run this. So let me do this. It is not required right now, but let me do this. It now. Fine. Okay. You need to restart the kernel. I will not restart it. This is not needed right now. Fine. If you guys have installed NumPy, then after installing NumPy, you have to import this library inside your program. So for importing the NumPy, we have to use import, import, import NumPy, numpy NumPy as np. What it means? This np is an alias. Alias means every time we do not need to write this whole line NumPy. Instead of this NumPy, I will use np from now onward. That it means. That means in our program, wherever I will be using np, it means NumPy. So we have to import it. So let's import it. Fine. Now it is imported in our program. After this get imported, now let's first create one array. So how I'm going to create array? Just write a is equal to, for creating an array, we will keep on using, instead of NumPy, we will keep on using np. So you have to write np dot array array, and thereafter you have to write this 0, 1, 2, let's write 3. So I want to create this array. So let's run this. This array has been created. Now I want to print it. So what you have to write? Print a. You have to write print a, and if you will run, you will get this 0, 1, 2, 3. The array that you have created got printed here. So this get printed here. Now let's create an array by another way. So this is one way to create an array. This is my array, 0 array 0, 1, 2, 3. There's another way to create the array. Let's use the another way. I am writing print because I want it to get printed. If I write np dot arange, 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 and then if I provide some argument, let's say I am giving 10. If I will do this, so what it will do, inside this arange, if I will give this argument 10, it will create an array starting from 0 till 9, because the last thing is not included, the upper limit is not included. That's why, and it will always start from 0. So let's create it. So can you see 0, 1, 2, 3, 4, 5, 6, 7, 8 till 9? The array is created. Fine. This is one way to create the array. Now, since I have told you before also that the array is memory efficient, array is memory, NumPy is memory efficient. So we will understand how this is memory efficient and all those things, how it takes, and also it is memory efficient and it provides fast numerical operation and provides fast numerical operations. Fine. So I am going to write one simple program, and I will write the program with the help of Python list. First, I will use Python list, and I will check how much time it takes to execute that program. Thereafter, I will write the same program with the help of NumPy, and I will see how much time it takes to execute the same program with the help of NumPy. So let's create one Python list. I am creating one Python list. Now, how to create a Python list? Simply I am writing L is equal to range. And Varun, if you ever face in my explanation, if you anytime, anywhere, wherever you face any difficulty, please keep on asking questions. Don't wait, keep asking questions. Is it fine for you, Varun?
Okay, sir.
हाँ, तो सवाल जवाब करते रहो, कोई दिक्कत नहीं है. Range, I want to create one list. So I am creating, first I want to create a list. So first I am generating one number from 0 to 999, 999. What this range 1000 will give? This range 1000 will give me a number from starting from 0 till 999. This thing we already have done. Now I want to create the square of the number. I want to create the square of this number which I have generated there from 0 to 999. So for that, what I will do, I am writing one list comprehension. So I square for I in L. So this is how it will generate a range of a list of number from 0 till a square of the list of number, a square of the number from 0 to 999 in a form of list. And I want to check how much time it takes our program to execute this. So for this, let me write this. You have to write this percent time, 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 it. If you will simply write this and you will run this, let's see what happens. See, it is telling me to execute this line of code. It took 30.2 microsecond plus minus 286 nanosecond per loop. And these are the things that it is giving: mean, standard deviation, 7 run, and all this 10,000 loops each. That means for completing one loop, it took itna microsecond, 30.2 microsecond. Now wait. Now I am going to do the same thing with the help of NumPy and see what happens now. So let me write np.arrange, and instead of let me give it a supply it a value 1000. Same thing. I want first I am creating a range of number from 0 to 999. For that I am using this. Thereafter I want to square each of the elements inside that array, and I want to check the time it took. So let's check it by this thing. time, and 8, thereafter a, and I want to square this. So if you run this, let's see what happens. Now, if you carefully look at this, you can see, if you carefully look at this, you can see it took 30.3 microseconds. And this is taking nanosecond, 528 nanosecond. Microsecond and nano. Nano is a much smaller unit than the micro. So, to execute the same program, plus minus, this is a nanosecond also, this is a nanosecond also. So, if you look at this time, entire this time if you look, and entire this time if you look, this is a very much almost 100 times, maybe 100 times lesser than the time. This time is 100 times almost greater than this time. This is a nanosecond and this is a microsecond. So, to execute the same program with the help of NumPy, by using the NumPy, I have completed it in much smaller time than the Python, the normal Python, with the help of the Python list. It means NumPy is much more time efficient. It is very much efficient. That's why, because the makers of the Python has made of this NumPy has made this library in such a way that it is very much memory efficient also, and it is very much time efficient also. That's why it is taking me much less time than the normal Python list. So this is just a understanding how this is, how it provides fast numerical operations. So this is a very simple program to understand this. Now I'm moving ahead. Let's clear it out. And now let's move to the next thing. Now, let's understand one thing. Let's create first. We will keep on understanding one by one, and we will keep on going slowly. And we will first understand very basic thing. Then first let's write one-dimensional array. What is one-dimensional array? We have already understood this. Let's create one-dimensional array. For creating a one-dimensional array, you have to write np.array. Thereafter, you have to give a list. You have to supply a list of numbers. Let's say I am giving it an integer value 0, 1, 2, 3. This is, let's say, my list of this is an integer value. So this is an array. Inside the array argument, I am giving a list. This is a list. So this is a list. This is a list. So inside this array, we are giving a list 0, 1, 2, 3. I want to create an one-dimensional array. So for creating an one-dimensional array, you have to write like this. So let's now run this code and see what happens. Let's print this also. So let's print. If you run this, you will get an array. What it is telling you? It is giving you an array 0, 1, 2, 3. That means it is an array. You have created an array, and inside this array, the list of element is 0, 1, 2, 3. Now, I know from my previous knowledge that this is a one-dimensional array. But let's say I want to understand what is the dimension of this array? Print dimensions. Let's see. So what I will do? Simply you have to write a dot ndim. This thing ndim. This thing will give you the dimension of an array. So here, when I am writing a dot ndim, it is giving me the dimension that it is a one-dimensional array. Fine. After that, I want to know the shape of this array. From my knowledge, I already know this array contains how much element? 4 element is inside, and shape means element is 4. So, and shape means what is the row, how many number of rows and how many number of columns it is having. That means that is called a shape. So let's check the shape. So for checking the shape, you have to write a dot shape, shape. If you will run this, so you will get 4 comma nothing, because it has got 4 column, sorry, rows, 4 rows. That's why it is getting you this. Now, there are 4 elements inside this array. So if you want to check the length, just like in list, we used to check the length, you have to use len function and you have to give this a, and if you will run this, you will get 4. That means it has got the length of 4. Similarly, this is a story of 1D array. Now let's create 2-dimensional array and 3D array. Let's create 2D array, 2D, comma, 3D, 3D array. So for creating the 2D array, what I will do? Let's take B and let me write np.array. This time 2D, you have already learnt about the 2-dimensional list. So what we have done inside a 2-dimensional list, studied inside the 2-dimensional list, we have studied that what is 1D list. 1D list was like that. This is my 1D list. If I want 2D list, list inside a list, nested list, one list inside another list. This is a 2D list. What is my 3D list? List inside a list inside a list. This is my 3D list. This is how it works. 1D, 2D, 3D, list inside a list, list inside a list, list inside a list. This is. Similarly, now I want here 2D. I want here, I want to print 2D array. So I have to give a list inside a list. So this is my outer list, and inside this list, there is a collection of lists. So let's write one list 0, 1, 0, comma 1, comma 2. Sorry. 0, 1, comma 2. And thereafter, inside this list of list, another list 3, comma 4, comma 5. I don't require this. Let's erase this. Fine. This is a list inside my list. I have to give this. Fine. There is one outer list. Can you see? This is my outer list. This is my outer list. This list is my This is my outer list, and this is a inner list. This is an inner list, this is an inner. So there is a collection of list inside a list. Inside the outer list, there are two lists. Fine. So this is how we create two-dimensional array. Now let's run this and see what happens. If I run this, let's see what happens. I want to print this also. So let's write B here. So, and let's run this code. Let's run this code. Fine. So this is how the two-dimensional array is got represented. Can you see a list inside a list? Now, one important thing, if you can check, just we have checked in the one-dimensional array. If you will check the dimension ndim, you have to simply write ndim, and you will check, you will get the dimension 2. Similarly, here if you will check b dot shape, just like we have checked earlier, you will get 2, 3. What it means? Let's understand this 2, 3. Here the shape is coming out to be 2, 3. What it means? 2, 3. So this 2 represents rows, and 3 represents columns. That means this array is having 2 row and 3 column. How this is? If you will look here, if you will, let me write it here in this way. This is 0, 1, 2, and this is my 3, 4, 5. So this is two row is there, first row, second row, and 3 column is there, first column, second column, third column. R1, let's write R1 and R2. Let's write C1, C2, and C3. This is how row and column concepts come in case of the two-dimensional arrays. So you will get row is in this form, column is in this form. That's why I am getting 2, 3. Now, similarly, you can even check the length. If you will check here length B, you will get the length of 2. Why I am getting length of 2? Because inside this, this is a, it is like, it is first checking, first length is this first list, and this is a second list. This is how the length is calculating here. Now, here length, let me write it here. Here length will return, it returns the size of the first dimension. Dimension. Now, let's create a 3D array. How you will create a 3D array? Just like the 2D array, we have to create a 3D array. np.array, first you have to write. Now, inside this, what you have to write? You have to write a list inside a list inside a list. Let's write first list. This is a second list, and inside this second list, I have to create a collection of lists. So let's write the list, comma 1. Then I am writing a second list, 2, comma 3. Then I am writing a third list, 6, 7. So let's create it this way. Fine. Let's create this list. This is how list inside a list will get created. Can you see this? This is how the 3-dimensional array, we can create a 3-dimensional array, or you can create any dimensional array with the help of this thing. You can also create n-dimensional array. I am creating here a 3-dimensional array. Let's print this and see what I will get. So let's run this. Can you see? 3 square bracket here, 3 square bracket here. This itself signifies it is a 3D array. And how this is in the form? This is in the form this is the first element, this is the second element, this is the third element, this is the fourth element. This is how we can see the dimension of the array by c.ndim. This will give me the dimension of my array. So this is the dimension of my array. I am getting 3 dimension. Dimension is 3. Similarly, if I can check the shape, so let's check c.shape. And if I will check, I will get this thing, c.shape. What is the shape of this array? What is the shape of this array? This is the shape of my array, 1, 4, 2. Similarly, I can even calculate the length the same way. I have calculated this. So let's write length c and see what happens. Fine. So we have understood till here what is the shape and all those things of this thing. Fine. Now let me yes.
Sir, in these shapes, sir, what this one stand for? सर 1 क्यों आ रहा है यहाँ पे?
ओके 1 क्यों आ रहा है शेप में?
यस सर.
ओके शेप में हम क्या कर, लेट्स अंडरस्टैंड दिस व्हाई 1 इज कमिंग हियर. Okay, let me explain you this. See, when there was a 2D array 2, 3, it means this is my row, this is my column. Fine. This was a case of 2D array. Now in case of 3D array, 1, 4, let's say, and this is 2. This is a case of 3D array. So 3D array has one more dimension. You can call it a row, column, or depth. So this is actually a depth. You can call it anything. This is a row. This is a column. And this is a depth. That is a third dimension. Fine. So this third dimension is, this is a 3D array. That's why this row is coming like this is my first row, this is my second row, this is my third row, this is my fourth row. So I am getting this 4. Now column I am getting 2. This is my first column, this is my second column, so I am getting this 2. And another is my depth. You can just understand this with the help of this cuboid. Let's say this is my cuboid. Let's understand this. This is, let's say, my cuboid. This is my cuboid. This is my cuboid. So one is, so let's say this is my row, this is my column. Let's understand in this way. This is my height, or you can say depth. Let's write it row. This is my column, and this is height or depth. So here depth is my third dimension. This one. Do you understood this, Varun?
Yes, sir. Understood.
Any confusion?
No, sir.
Fine. So shall we move ahead? So let's fine. So let me erase this. Fine. So now what I have written here, when you will calculate the length, it returns you the size of first dimension. That's why here when I am calculating the length of C, it is returning me 1, because 1 is the size of my, it is returning me this dimension, size of the first dimension. That means depth. That's why 1 is coming here. Now let's move to something else. Now I'm going to understand this with the help of something more. Let's write this thing using a range function. Using a range function. Fine. Let's write a here, and np.a range. This will help you to create an array. Let's write, if I give it an argument 10, it will create a array starting from 0 till 9. This works like this works from 0 till, you can say, n minus 1. So whatever value you will give, argument you will supply here, it will give you value 1 less than that, because it will start from 0. So if you run this, we have already discussed, you will get this thing, array 0 to 9. Now this is, till here everything is fine, you must be known. Now what I'm trying to explain you is, if let's say this is a B, now I want to create np.range, and if I write, let's say 1, 10, 2, what it means? It means I am asking this, and let's write here B. What it means, let me explain you first. This is my starting position, or starting. This is start. This is end. And one very important this thing is that you have to remember, This AND is exclusive. Exclusive. That is, it is not included. Your start thing is included, but your end thing is not included. It will always be like n-1. Just now I have written here n-1. So when you are using np.arrange, your end thing will not get included. So I am writing this like this. And this is your step size. This is called step size. What it means? You are asking it to create an array from 1 to 10, excluding 10, in a step size of 2. That means it will create, first it will, 1 will come. Thereafter, if you will look at here, this first 1 will come. Thereafter, it will jump 2 values. So this 3 will come. Thereafter, it will jump to 2 and this 5 will come. Thereafter, it will jump, 7 will come. Thereafter, it will jump and this 9 will come. So total, what you will get here, 1, 3, 5, 7, 9. You will get this thing. Since 10 is not included, and you can see this is creating an array with a step size of 2. So whatever size you will mention here, it will create according to that. Hope you understood this. Now let's run this code and see. Can you see? Same thing, 1, 3, 5, 7, 9. Now let's, using line space, there is one thing called line space, using space space. So let's create one array. A is equal to np dot lin space space. If you will use this, and let's set 0, comma 1, comma, let's write 6. And if you will print this, what you will get? First, understand what this is all about. So what this is going to do for you, it will take this first thing. This is my starting position. This is my starting position, start value. This is my start value. And this is my end. So let's put a start 0 here and end, let's say 6, let's say 1 here. And what it is telling, this linspace is doing, it will create 6 points in between with a equal spacing. It will create 6 points, including these 2 points, including these 2 points 0 and 1. It will create 6 points, 1, 2, 3, 4, 5, and this 6. That means 0, 1, 2, 3, sorry, 1. So it will create, this is 1, 2, 3, 4, 5, 6. And all the points are of equal spacing. So this is a point 2, this is my point 4, this is my point 6, this is my point 8, and this is 1. So in total, it will create 6 points with a equal spacing. So this is my number of points. This is my number of points. Number of points. Fine. This is how it works. So let's run this and understand. Exactly, it will give me same thing. So can you see 0, 0.2, 0.4, 0.6, 0.8, and 1.0. This is how lean spacing works. Fine. Now, there are certain common arrays which we are going to understand this, and you must be knowing this, but we will going to understand this with the help of code. Some common arrays. Let's write some common arrays. Common arrays. Arrays. So let's write A. This is called, if you write np, sorry, A is equal to, if you write np dot ones once, and let's give it 3, 3. If you simply do this, if you print this, you will get, this is also, I suppose, this is also called identity matrix. And if you run this, you will get this array of this, in which every element, what I am asking it to create a 2-dimensional array with 3 rows and 3 columns. So 3 rows is there and 3 column is there, and each one of the element inside this array is 1. This is also called identity matrix. You must have studied this in your, I suppose, 10th or 9th class, or maybe in 11th or 12th class also. So this is how we can create the identity matrix, a array, np.ones. Now let's create some called, this is also called np. If you will simply write np dot zeros, and let's give it 3, 3. Let's put, and let's run. It will give you here, when you will do this np dot zeros, every element inside this 3, 3 matrix or 3, 3 arrays is 0. Now, if you will do, let's write C is equal to np.i, I. And if you will write, let's say, if I am writing this 3, and then if you will print C, what it will give you, this will return you, let me write it here, this will returns, returns, returns a 2D array with ones on the diagonal and zeros elsewhere. Fine. If you will simply run this, you will get this. What it means? First, let's understand what is diagonal. So any matrix or any array, you will see, let's write this 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's say this is it. So this element is, this is called diagonal elements. 1, 5, and 9. This is called diagonal elements. Rest of the element, this is called diagonal elements. Rest of the thing is called non-diagonal elements. Fine. So these are the non-diagonal elements. So this np.i, when you are writing this 3, what it will return a 2D array with ones on the diagonal. It will create a 2D array with ones on the diagonal and zeros elsewhere. And 0 is elsewhere. Fine. 2D array means having a rows and column. So this was very important thing to understand. Now let's move to the next thing. Now, if you will simply do d, I am writing d is equal to np dot I, and if you write 3 comma, let's say 2, what this will give? So here, let me first run this and then I will explain you. Let me first run this. If you will simply do this, what will happen? Let's see what is happening here. In this, first it is, let me write it here like this. First, it is actually writing in this way 1 0 0 0, then 0 1 1 0 1 0, then 0 0 1. So this is my this thing. This is my this thing. So what it is actually doing? So what it is actually doing? np.I 3 comma 2. So it is basically taking all the three, it is basically taking only the 2 columns. It is taking only the 2 columns, and it is taking only the 2 columns. That is, 3 is the number of rows. 3 is here, 3 is the number of rows. Row will remain the same, but 2 is the number of column. So column will also be remain, 2 is the number of column. Row will remain same. 3 I am writing, so row will remain same here. So I am getting the first row, second row, and third row, but it will take only 2 column. So this column it is taking, and this column it is taking. It is not taking this column. It is not taking this column. That's why I am getting 1 0 0 1 and 0 0. It is taking only this thing. It is not taking this thing. So this is how it works. I will also write it for you here, so that whenever you will see, you can able to understood this. So let's write 3 is number of rows, comma 2 is number of columns, and index of diagonal starts with 0. Index of diagonal null starts with 0. Now, moving ahead, let me write something called, now let's write one thing, one very important thing here. Create an array using, there is one function called create an array using diaz function. So let's create it. A is equal to, let's write np dot DIAZ, and let's write 1, 2, 3, 4. If I write simply this is what this will construct, and this will construct a diagonal array. Construct a diagonal array. Let's run this. So let's run this. Can you see? This is going to construct a diagonal array 1, 2, 3, 4. So in this 1, 2, 3, 4 comes in the at the place of diagonal elements. It is putting this 1, 2, 3, 4, and the non-diagonal elements are all 0. This 1, 2, 3, 4 is coming in place of diagonal elements, and apart from this 1, 2, 3, 4, all the non-diagonal elements are 0. Now, see, let's suppose this A has been created, and you want to extract the diagonal elements of any array. Then what you will do? Simply you have to write np.diaz, and thereafter you have to supply it an array whose diagonal you want to extract. So here I am giving it an A. So it will give you the elements that are present in the diagonal. So 1, 2, 3, 4 is present inside this array. Diagonal elements is 1, 2, 3, 4. So I am getting 1, 2, 3, 4. Now today I am going to discuss two more things. Thereafter we'll see. So now let's see one thing. I want to creating array using random. There is one thing called random. Create array using random. So this is very useful in case of uniform distribution, probability, this thing, the application of this you will find it. So let's first understand how you will create random, how you will use this and create. Let's write A is equal to np.random. You have to write np.random, random, random. Thereafter dot you have to write rand, rand, and let's say you want to create 4 random elements. So let's say if you will write this, and you want to see what it is going to create. So let's do this, and if you will run this, it will going to create 4 random. It will going to generate 4 random value from 0 to 1. In which 1 is not this. What this is going to do, let's understand this. What this is going to do, this is going to create from 0 to 1, where 1 is not included. It will, whenever you will do this random.rand, and whatever argument you will supply here, let's say I've given 4 here. So it is going to create 4, it is going to generate 4 random number from 0 to 1, where 1 is not included. This is a sign of not included. 1 is not included, but here 0 is included. So this is a random sample. It will give you within from 0 to 1. Fine. So let's have done it, run, let's clear it out. Now, let's write this thing here, something, create it is going to create a rand. It will, what, let me write it, create an array of the given shape and populate it with random samples from a uniform distribution over over 0, 1. This thing will not come. So it will create a uniform distribution. Now, one next thing is that if you will, instead of this thing, you can also write np.random. Instead of this rand, you can write rand n. This is going to return you something different. What it is, let's first see what it is going to return you. Let's first give. Can you see? Even negative value is coming here. Even 1 is coming here. Here you were getting only values from 0 to 1. 1 is not included. Even the negative value was not included, but here negative value is also included. Actually, the concept of this, I will going to discuss it in statistics and exploratory data analysis. When we will be doing that, I will be discussing. Let's understand how this is coming out to be. And it will return, this is going to return a sample from standard normal distribution. This thing, standard normal distribution. This concept, standard normal distribution, we are going to study in statistics for AI. When we will be covering the statistics for AI, we will be covering this. And this is also called Gaussian distribution. Standard normal distribution is called Gaussian distribution also, or let me write it here, Gaussian, G-A-U-S-S-I-A-N, Gaussian distribution. So the concept of standard normal distribution, I'm not going to discuss right now, because these things I'm going to discuss in a very detailed way in statistics concept and exploratory data analysis when we will be doing. So we will be discussing this standard normal distribution there. So this thing will generate an standard normal. It will generate you a value in a standard, in the form of standard normal distribution or Gaussian distribution. So whatever element it get generated, it will follow the norms of standard normal distribution or Gaussian distribution. So I suppose this is all for the day. The next thing we will going to discuss it tomorrow. So there are a lot more of things. Still, I'm like, we have done only 10 or 20%, like 10 or 15% of what you have to do. So we will cover it in the next session. So if, let's do one thing, let me first commit my code. Let me first do this, save this entire code. Then let's commit it to GitHub. So this is a NumPy session 1, NumPy session 1. Let's commit it. Yes. Sync changes. Okay. Fine. Now if I can go to my GitHub and see all these things, is it available or not? Let me see it. Let me see this thing. So just close this. So let's, so this thing is available here. Can you see basic NumPy 1, NumPy session 1, or whatever code I have discussed right now, everything is available here. If you will check this, if you will check this, every code is available here. I will attach. You can see everything is available here. You can download it from here. I will attach you this sheet inside the description section of the video, the GitHub link. From there, you can download this sheet. Fine. So let me stop sharing my screen and let me open my camera. So hello वरुण, कैसा रहा आप आज का सेशन? कुछ समझ आया आपको? मजा आया? बहुत ही
sir.
बेसिक चीजें हम लोग डिस्कस कर रहे थे।
Yes, sir.
आया समझ? कोई कुछ इश्यूज,
Yes, sir.
कुछ आज के सेशन से रिलेटेड कोई डाउट्स, कुछ समझना है आपको, कुछ पूछना है?
नहीं सर, आ गया था समझ में।
ठीक है। So we will continue doing the NumPy thing, and it will take us maybe 3-4 sessions. It will definitely take 4 sessions. So we will going to cover it all. And this is all for the day. So guys, keep on watching videos, keep on suggesting, and keep on requesting. So I'll love to create a videos or take online sessions, live session as per your request. So this is all. Thanks Varun, thanks for coming, and keep coming, keep learning, keep smiling. That's all. So